Hello, everyone. Welcome to the January 2013 Professor Messer Network Plus Study Group. This is our first Network Plus Study Group of the year, and it's one that I like to do every month where we take your questions, we go through some different topics relating to the Network Plus certification, and hopefully at the end of this, we'll have both learned something as we've gone through the process. I have quite a number of things to go through this month. Normally when I'm putting together this presentation, it's usually the evening before, and I go through all of your questions and I'm looking at what's available to answer. And again, this month you've given me just a lot of questions that are here. Before we get started, this is a study group that I do every month, and I do it because really from your support. For those of you that have been on my website before, the website is one that provides a lot of free videos, a ton of free videos. Every single video I make is absolutely free. But for those of you that like to go offline with your videos, you like to have an actual case of DVD-ROMs with my videos inside of them, you can buy them on the website. And of course, the people that help keep the website going do purchase them because they can take them offline. They can put them on their mobile device. They can just drag and drop them onto their Android or their iPod type device, their iPhone, and get those going as well. If you want to know more about that, you can go to the Professor Messer website, specifically professormesser.com/download-network plus. And also let me if you're just someone who doesn't need to buy this and you'd still like to help support what we're doing here, some things that really help support us is by following us on Twitter. If you go to professormesser.com/Twitter, and perhaps even more importantly, subscribing to us on YouTube. I'd like the folks at Google to know that we have a ton of supporters here, and we're getting about 350,000 views every month. It'd be nice to get that number up and really make an impression. You guys are being very vocal in your viewing of this. You aren't saying a word, and yet the folks at Google are certainly noticing what you're doing. Go to professormesser.com/YouTube, and you could subscribe to the Professor Messer channel. That actually helps me an amazing amount. So I appreciate all of the support that I'm getting from you. As I mentioned, I do these every month. And a lot of the times the questions you send me are exact duplicates of what we just went through, and maybe just didn't realize that we're doing one of these every month. So, and if you go to the Network Plus page where all of my Network Plus videos are on the Professor Messer website, down at the bottom are the replays for all of the study groups. So it's a great way to go back and see what we've done. Well, last month in December, we did quite a few different topics. Do you really need the OSI model in the real world? You're having to memorize this OSI model. Do you really need it? Seriously? And we answer that question. How do you memorize all of those different network ports for the exam? We talk about that as well. What are the main differences between SMB and FTP? We have, can you explain how Wi-Fi speeds relate between the ISP, your local network, your wireless adapter? There's so many different speeds to and from. How does that work? How much of a security risk is using public Wi-Fi hotspots? When you go to get some coffee, you go to a hotel, you go anywhere there is free public Wi-Fi or even paid for Wi-Fi, is there a security risk there? And if so, what is that? We're going to talk more about that this month as well. And what qualifies you to be, not me, but all of us, to be Tier 1, Tier 2, or Tier 3 network support people. So those are just an example of some of the things we talked about last month. If you'd like to know the answer to those, go back and watch last month's study group, and you can learn all about what was going on. If you have your Network Plus certification, and you'll notice, of course, that if you've taken it recently, it is good for 3 years. And after that 3 years, it has to be renewed or you lose it. So sometime during that 3-year period, you have to go through a renewal process. One way to do that is to get these continuing education units. And to learn more about what you can do to earn those CEUs, you can go to certification.comptia.org/CEUFAQ. And there's a nice big document there that explains to you what is this process of renewing your certification. Now, some people simply take a higher level exam, which automatically then will renew all of your lower level certifications. That's a relatively easy way to do it. Certainly in one fell swoop, an easy way to do that. You can also gather these credits. And if you're in the networking industry, the computing industry, the IT industry, as you read through this FAQ, you'll notice it's really easy to get these certification units. Very simple, these continuing education units. So read all about that. If you have questions about it, talk to CompTIA. They'll tell you exactly the format. It's exactly the things that they're looking for. If you want to know more about just the generalities of these CompTIA certifications, I've done some frequently asked questions videos. And if you go to professormesser.com/FAQ, which you really can't read too well there, you really can't read it too well there. There you go. professormesser.com/FAQ. You can see all of these different topics that you can learn about. What do you expect to see on the exam? You are now ready to schedule. What should you think about? What type of jobs can you get with certification exams? Some of these are specific to A+, but most of these Q&As do apply across the board. So that might be something to think about as well. And I announced this last week on our A+ study group, but I want to be sure everyone on the Network Plus study group sees this as well, as we've hit 10 million views on YouTube. Really 9 million on YouTube and 1 million from other video sites. So we've got 10 million views overall. What a fantastic number. And I wanted to take a moment and thank you for doing that, for watching the videos, for going through the training, and for doing those things. It's very motivational to see those numbers keep going up. And as long as you're going to keep watching them, I'm going to keep making videos. So everything you're doing there is much appreciated. Thank you so much. One of the things I want to know from you then, before we get going, and a good check to see if we're going to be able to communicate here with this, is for you to answer a question. So there's the part where you can participate this week on the Network Plus study group this month. You can tell me how long you've been studying for your Network Plus certification. If you take your QR code reader and you snap a picture of this QR code, make it a little bit bigger for you, you can then have your browser take you right to the right site. But if you don't have a QR code reader, just type into your browser on your mobile device or pop open a new tab on your existing browser and go to vote.rs, vote.rs, and use the code 972984. That's 972984. And I'll pop that up on the other screen here so we can all follow along on this piece. Here we go. So how long have you been studying for your Network Plus certification? You go to vot.rs, the number 972984. We've gotten 11 respondents so far, so we can see the numbers moving up. And what I'm going to do, since this is not something that is a secret, I'm going to show the answers to this and what we've got so far. We'll have this bounce up. So as you respond, you'll notice that the graph will also move correspondingly. So this is the way that you can tell me and give me information about the things that you're thinking about as we go through the study group today. I have lots of questions for you. Some of them are questions to help you reinforce some of the topics that we're going to think about. For the most part, it looks like a large number of you, less than 3 months, and even a little bit smaller number of you, 3 to 6 months, and then you have a few people after that. So most of you have been really going at this for 6 months. Now, if you're like me, I fit in that longer period. When I'm studying for a certification, I have the day job, I have the night job, I have the family. We have to do things on the weekend. There's just not enough time to study. So I get a little piece at a time, So sometimes it does take a number of months, or you start on the certification and then you don't do it anymore. Then you come back to it. So you've been studying a year, really, 2 months here, and now I've started up again. But obviously it takes quite a bit of time. As we go through the study group today, I'll keep this in mind and make sure that the topics we're dealing with and how we're going through them are really based around people that have been doing this for about 6 months or so, sometimes a little bit longer, sometimes a little bit less, and that way we'll be able to keep up with what we should expect to know about on our study groups. Let's flip back now to your questions, because I asked you to send me all of the questions that you had on your mind about the CompTIA Network Plus exam. I asked you to tell me what types of things were challenging you the most. You've left me a message on Twitter. You've left me messages on Facebook. I've sent out in the registration. You'll notice I asked you to leave me a question. And for those of you that did, I have lots of questions to go through. The first question, before we get there, I have a test for you. We're going to use that capability to answer these questions. And I'd like to know what type of fiber commonly uses laser beams as a transmission source. There's one type of fiber that does use this. Don't answer in the chat rooms. Do not answer. Do not type this into the chat room. You need to go to vot.rs and use number 583279, 583279 to be able to do that. 583279. Let me flip that up on my screen so you can see that, and we'll just follow along And so you'll see there are some options there. We'll look at them right now. It's not an open-ended question. I give you some ideas of what you can see on this. So I'm going to hide the results. I like this hide the results. So what type of fiber commonly uses laser beams as a transmission source? I just can't do that enough. 58, 32, 79. We have 16 people that have responded, 17 so far. So the options you have are multi-mode fiber, hybrid mode fiber, single mode fiber, large core fiber. So we've got quite a few options in here. Some of these I expect that you have heard of before. Some of these you might not have heard of before. Did I make up some fiber types when I was building out this question? I might have. I might have made this a trick question with things that don't even exist. Let's see the answers. We got 26 people that have interactively sent this in here. I'm going to go down to a view I have at the bottom, and let's show the results. And we have multi-mode fiber. 10 of you said multi-mode fiber. 3 said hybrid mode fiber. 14 said single mode fiber, and 2 said large core. And in this case, 14 people, those 14 under single mode fiber, absolutely correct. It is single mode fiber where we most very commonly see very high powered types of methods being used to transmit that light through the fiber. And obviously one of the highest energy methods to do that would be laser. It doesn't always have to be laser, but that is a very common type of method to send that light through a single mode fiber. And as mentioned in the chat room, do not look into a fiber. That's why you absolutely do not look into the end of your fiber connection and say, hey, is there anything coming through here? Because if there is a laser or really even a bright light from an LED that is being sent through there, that'll damage your eye. Don't look into the end of that fiber. It's a very, very, very bad idea. Always get us. There's very simple and very inexpensive fiber testing tools that will tell you if any light is coming through and how much. That's what you should be using. A very, very easy way to do that. Multi-mode fiber is not commonly used with laser beams. Usually it's an LED or another bright source, but laser is a little too unnecessary. It's very powerful. Certainly it could be used, but that's a very powerful light source, and multi-mode fiber doesn't tend to go long distances, so we don't need a relatively very bright light source. Hybrid mode fiber I just made up. I don't even know what that means. There's no such thing, really. So that's not the answer. And large core fiber, I guess you could also call that multi-mode. Multi-mode is the core or the middle of the fiber is relatively large when you compare it to a single mode fiber that's relatively small. So I guess large core could be called multi-mode, but we don't call it large core fiber. We call it multi-mode fiber almost always. So that's one of those things that we ran into. And for those of you that answered single mode fiber, you are absolutely correct. Thanks for participating in that little Q&A. And the reason I mentioned that Q&A is the first question that came through that I got was, is distance the only advantage in using single mode over multi-mode fiber optic cable? Because that's the one you always hear about. Well, we need to go a long distance. We need single mode fiber. First, let's take a step back from SK's question, and let's look at both of these, because multi-mode fiber is built differently. It uses light in a different way. It's a completely different way of handling the light going through a fiber. It's primarily used for short range communication. If you are in a data center, if you're between buildings that are relatively close to each other, and I put here up to 2 kilometers, but it's almost very, very short segments. This is what you would use multi-mode fiber. If you go into a big data center, and these big data centers can be enormous. They can be kilometers long in some cases. Most of the time you're going into a data center that's a self-contained room, pretty small. You can see from one side to the other pretty well. And you'll notice that almost all of the backbone, everything that's connecting all of the different rows together and communications even between devices on those rows, will commonly use this type of fiber connection for a couple of reasons. First, the short range type of capability is nice. But the part that's probably most important in some of those environments is you don't have to worry about interference. So this goes back to the question that was asked, is that really why you'd use single mode over multi-mode? I guess it's a reason why you'd use fiber over anything else, is you can't have any type of radio interference if it's something like a fiber technology. Multi-mode fiber, as I mentioned, doesn't use lasers most often. It's most commonly uses something like an LED to send light through. And the way that it goes through, I mentioned it's a bigger core. You can even see in this picture that the middle of the fiber is relatively big. And as the light goes in, it might bounce around in a lot of different ways as it goes down the fiber. So it has multiple modes that you are seeing as it goes through that connection. Here's one mode that's taking a bounce right off the top. There's another mode that's coming in at a different angle. Here's a third mode that's coming in at a completely different angle. Multiple modes. That's why we call it multi-mode fiber. There is also pretty interesting when you start looking at the other types of fiber. Single mode is one that is got a much smaller core. You can even see, I haven't made this to scale, obviously, but if you look at it from a relative size, you have a very narrow core. And because of that, there's not a lot of room for light to bounce around. So you get a single mode as it's going through that connection. Now, because you're really taking a single mode of that light, everything else doesn't go into that fiber, you're pretty limited as to the capabilities. You need some bright light going through here, and you're usually using single mode when you have to go a long distance. So if you are a service provider, if you are someone who has to take that signal and send it to the other side of town, or you're plugging into a provider that is giving you a fiber connection, you're usually plugging in your connection on one end, and the service provider is using single mode fiber to get it to the other side. You can't really see, maybe you can see the single mode fiber when it comes into your building, but you're not really responsible for any part of that. You'll notice they're always using that single mode fiber. It's almost always using an expensive light source like a laser to be able to do that. That's why when we're plugging in switches in the same room and we're using fiber, you'll notice it's using multi-mode fiber because of that. And it's very common to see the multi-mode fiber in one that is in an orange cladding, an orange outside color. And the single mode fiber tends to use a yellow color. So if you're ever looking at pictures of a data center and you notice that some of the fiber is colored orange and some of the fiber is colored yellow, that is a good tip-off as to the type it would be. Now, that's a standard, certainly standard for civilian. There's different standards for military. But for civilian use, those are the colors you would expect to see. You don't have to follow those standards, of course, but if you happen to see that in a data center, that's what that's all about. The primary reason, as the question asks, is it really just for distance? It really is just for distance from an engineering perspective. If you're planning to connect different locations together, you're planning to connect one side of the data center to each other, you would measure how far that is, and you would make an engineering determination. Can we do that with multi-mode? Because it's less expensive. It's less expensive components for my switches, for my routers, for my servers. It's less expensive fiber itself to run over that long distance. It makes sense to always start with multi-mode, but if you go even further, or you're right on the edge of what you think that multi-mode might want to do, maybe you want to engineer in single mode fiber to do something like that. A very good question coming in for that. And I think if you're ever planning to engineer anything with fiber, you need to get very comfortable with those technologies and exactly in what scenarios you might want to use the fiber pieces. There's other engineering concerns around that, but that is probably the most prominent one when you are planning a fiber-based installation. Let's go to our next question. What's the difference between a logical and a physical network topology? You'll notice on the Network Plus requirements that you need to look at documenting your network. And one of the things it mentions is you need to document the network physically, but that's different than documenting the network logically. Completely different ideas for documenting the network. And that's because the way that you would find things on the network and the way that you would think about traffic flows is different if you're looking at a physical picture of the network versus a logical picture of the network. Let's look at two different examples of this to really give you a feel for what this is about. This is a diagram that shows a physical network layout. And what it's showing is the different components, the different workstations that might be out here. It shows different switches that are in place. It shows different routers that you might be running and different connections through other routers that might be running out here through other types of connections out to other devices, switches, routers. This is one where you can actually go to this actual IP address. You can look in the back of it. You can follow the cable or the fiber down to the switch. In some cases, these pictures will even tell you what switch port this device is plugging into. And it may go through a patch panel here and there, but if you tried to physically map it out and follow the fiber and follow the cable, it would take you all the way up here to this switch. If you looked on the back of the switch, there is a cable, the G0/1 port, Fast Ethernet 00. You can see exactly what's being used between those two devices and see exactly what's there. That is one where you can really see physically how it's laid out. Now, the problem, if you look at this, is trying to determine on what subnets things might be. A really good example, probably not here, because you can see all of the IP addresses here are IP addresses that tend to be all in the same subnet: 172.19, 176.129, 130, 131, 132, 133, 134. But of course, on a switch, you can have devices that are on completely different subnets. They could be in different VLANs and yet all plugging into that same switch. So this could be a 10 dot network. This could be a 192 dot network. These devices could be on completely different networks. And if you were trying to look at this picture and determine traffic flow, it would be much more difficult to try to get an understanding of that. If somebody hands you a map and says, this physical map, and says, we're having a problem with our routing tables, please fix it, you would look at this map and go, wait a second, I can't really follow where the subnets are here. This is a physical diagram. If I needed to troubleshoot cabling, if I needed to troubleshoot and understand where somebody's plugging in or how different devices are connected to each other in the data center or in a different part of the network, this would be a great map. I need something that shows me routes because I'm looking at routing tables. I'm trying to troubleshoot routing problems. For those types of issues, you want a logical network diagram. The logical network diagram, notice, doesn't have all of those individual devices with lines going to them. Instead, it rolls everything up into a more logical view. So you can see the different subnets and exactly how they are connected through different firewalls, through different routers. You can see all the layer 3 routing that's going on here and where it happens to go to get out to the internet, to communicate between different subnets. So you should be able to look at a router configuration and know, in this router, I should see local subnets of 192.168.1.0 and 192.168.0.0. and be able to make a determination that that's where all the routing takes place locally for those particular subnets. There's also local routers here on this firewall and the other side of this router over on this side. Now that is something, and Steve in the chat room is making a mention. Wait a second, that's a lot of stuff. Now I've got to figure this out. Well, I'm showing you some pretty big networks in this scenario. In our home networks, we have an internet connection, we have a router, and we have a local subnet, and we're done. But the reality is this picture is just adding more of those same components into the mix. If you're in a home office, you're in a home configuration with your cable modem, your DSL, you probably have this right now. You probably have an internet connection. You have a wireless router, I'll bet, so you can have wireless connectivity and local wired connectivity. And all of that is connecting to a subnet that's on your local network, probably a 192.168.1.0/24. So you have the same network right here that is in your house. And when you look at a larger organization, it's the same thing. Don't think that when you walk into a data center that it's a completely different way of working. It's the same TCP/IP that you've always used. It's the same routing mechanisms and routing tables that you've always used. It's the same process to get data from one side to the other. Now, of course, there are some nuances and things that apply to the enterprise. If you're doing dynamic routing with OSPF and BGP, there's other nuances that you add onto that. But the fundamentals in the largest data centers in the world are exactly the same fundamentals that you're running in your house. That's one of the beauties of TCP/IP, of course. So if you're trying to get that Network Plus certification, you're trying to figure out, how am I going to take what I know on this exam and what I'm doing at home and apply that into an enterprise, it's a pretty simple leap. And you've got exactly the same protocols running exactly the same way. They're doing just as fine a job at running Netflix in the enterprise as you are at running Netflix at home, I assure you. So there are things that are very, very similar between the two. So don't get too thrown over looking at these physical and logical diagrams. In fact, try building out a physical diagram for your house. Try building out a logical diagram, and you'll get a pretty good idea of exactly the process that's involved and the types of things that it's trying to explain to you. It's a pretty good process to go through, and that's a very small network, so it makes perfect sense to start with that one. Let's now do another question. It's time for you to help participate The question that we have is, what port number is commonly used for encrypted web communication? If you go to vot.rs, don't answer in the chat room. Do not answer in the chat room. You want to go to vot.rs instead and use 320442. 320442 at vot.rs. Now, the reason I'm mentioning this is a lot of the questions that I get every month are, how in the world am I possibly going to remember all of these different port numbers? It was a question that I answered in the study group last month, so if you want more detail on that, go back to that piece. But go out to vot.rs and have a look at that. And I think what you'll see is a number of options available to you. Let me pull up the same view on my side. What port number is commonly used for encrypted web communication? I'm going to hide the answers from everyone. So the people that have, we have questions, 20 responded so far. It is TCP 80, UDP 443, TCP 123, TCP 443, TCP 433, TCP 8080. Got a lot of options there. We're talking about the one that's most commonly used for this. Now, of course, there's nothing preventing you from setting up a web server to communicate encrypted communication over any of these port numbers. You can tell the web server exactly what you want it to do. But generally, we have chosen well-known port numbers for our servers so that everybody else that's using a browser can use just what's commonly used for those encrypted connections. So that's what you would like to do. 32 respondents, 33. Let's look at the answers. So did you get it right? Let's find out. The answers are, let's see what people have said here. Well, you can see immediately 21 people have not been fooled at all. It is TCP port 443. I fooled somebody on the UDP port 443. Encrypted web communication is always done over TCP. It's almost never done over UDP. And I'm speaking specifically for HTTP. I said web communication to give you a feel for what I'm talking about here, just as a way to make the question a little bit harder. There is a TCP 8080. You commonly see that on proxies, and TCP port 80 is web communication, but non-encrypted web communication sent in the clear. So that didn't fool too many people on that one. You folks have a pretty good grasp on your port numbers. So you shouldn't worry too much about not knowing your port numbers. You folks are doing a pretty good job right now of keeping track of all of those. Now, I bring this up because there are a number of things that when we start looking at troubleshooting networks, at using networks, at finding ways to understand more about what's happening on the network, a lot of people will ask questions about, how can I learn more about this? What process should I go through for networking? What are the things that would be most important? And one of the questions that I got this month really hit on something that is near and dear to my heart, something I've been doing for a very, very long time, and that is Wireshark. And it's not just Wireshark, but really protocol analysis in general. If you want to be the person that knows everything about everything relating to what's happening on the wire, you need to get down and look at the protocols. You need to get down to that level and understand not just is there traffic on the network, but begin to understand the language. And that is probably the most important part of this. Wireshark is your universal translator. It knows how Ethernet communicates. It knows how TCP/IP communicates. It knows how port numbers communicate to each other. It understands many, many, many applications, hundreds and hundreds and hundreds of applications, and the languages that they use to communicate, because HTTP and web traffic uses its own language to talk from a browser to a web server. FTP has a completely different language that it uses, a completely different set of protocols that are in place that it uses. Oracle SQL Server uses a completely different language. Microsoft SQL Server uses a similar but still completely unique language in how it communicates. Being able to look at protocols and how they are communicating will tell you everything about what's happening on the network. If you wanted something that would really differentiate you, that whenever anybody said the network is slow, whenever anybody said this application is not performing the way it could or it should, this is the way that you're able to find out exactly what's going on, is through looking at the protocols. You can't hide on the network. If I capture all the packets that are going across the network, I see everything. That's why some organizations will use things like Wireshark, absolutely free protocol analysis. They might use something like the Sniffer product, that's a trademark of now NetScout in what it does. Those types of technologies can really give you some insight into what's going on. Now, if you have not used Wireshark before, you absolutely need to go out and use that. Let me pull it up on my side so you can, we're going to pull up Wireshark and just run through a few things relating to Wireshark. I'm going to pull it up full screen so you can see it here. And I'm just going to show you an example of what you can see coming through. I think that is one of the most useful parts of understanding networking is building from the ground up. The first time I saw a protocol analyzer, I was mesmerized. At that point, we were running a network. There was communications going to mainframes. There were communications going to file servers. There were communications going to other machines in the network. But I really didn't know what was going on. Had no clue the process in place for sending this information back and forth. And if you get into Wireshark, and there's some great tutorials out on the internet that can help you out with these pieces, and you can start doing some captures. So I'm going to actually choose I have an interface here that I can grab some data from. It's not going to be that one. It's going to be that one. And let's start. And what you'll start to see coming through are just tons of packets, because what I'm doing right now, quite literally, look at it go. We're at a lot of packets already. They're just flying by. That's because I'm taking whatever's on my screen and I'm sending it to the device that's then streaming it out to you. So it's like a remote desktop that's going on here, but it's one very specific to the software that I use to send you my video signal. So this is a lot of information going back and forth down this link. Now, while it's doing that, you can go out to any of the machines that you're using. Go out to your browser, browse out to Google, go out to communicate on the network and look and do an FTP and see what happens. I'm going to stop the capture here, and you can see I've got a lot of packets that I've captured. But here's something I'm going to do. I'm just going to take the first one that came in. This particular protocol that's being used, we don't know anything about it, but we actually know quite a bit about it. Even though we don't understand this remote desktop process and what's going on, there's actually a lot inside just one of these packets that we can look at. Now I'm going to go all the way to the top of this list because I think that's where this is pulling this packet from. Let's go all the way to the top. So I'm looking at this packet number 1 that I have on mine, and you'll notice there are 3 panes that you can look at here. And I realize this is very, very tiny, but I'm going to show you some of this stuff when we get here that will allow us to zoom up a little bit maybe. There's a pane on the top that shows you a summary view, packet by packet view of what came through, just as an overall view. Whatever you highlight is whatever you will see in the middle frame, the actual pieces that you see in this middle piece. And then at the bottom is a hexadecimal and ASCII representation of the data that you saw come through. So you may be able to look in here and see, am I seeing real words and real numbers come up here? That might help you. What I'm going to do is take this middle pane, there's these little arrows, and I'm just going to explode this particular packet. And we're going to get a feel for what's here. Maybe I can make this even a little bit bigger. Instead of the full screen, let's look at a different size here. Oh, there we go. Let's see if I can move this even around. Instead of centered, I want to select an area. We're going to do exactly that. And I'm going to move it over so we can see this little piece. So you're kind of watching as we go here. All right. So I've just exploded out this packet. Let's see what's in here. Now, the first part is just an explanation of what we've captured, which is a 66-byte frame, and we can see when it arrived, we can see time shift, we can see delta times from the previous and the next frame. There's a lot of detail in here. You'll notice that's why it's usually rolled up. A lot of that detail you don't always need. But once we get through the explanation of what the frame is, we've got this other frame that is the Ethernet section. So now we're looking at MAC addresses. Okay, now we're in the OSI model, right? Layer 2 with MAC addresses. So here is the source is this Apple address. That is the device that I'm on right now. And the destination is this other Apple address because it's talking to another machine that I have in here that's streaming out to you. So already, if we're troubleshooting and trying to figure things out, do those MAC addresses, are those what they should be? Is that the expectations that we have for this application? And in this particular case, it is. If you want to know more about these, there's even some additional information you can roll out in each one of these that will show you the actual breakdown of how those particular addresses are built. And this is coming right out of the protocols coming across, and it is an IP header that's in here of a protocol type of hex 0800. IP is an 8-port 80 or a hexadecimal 0800 is the name of IP. And IP is coming up next then. It's IP version 4. And you can see the source IP address is 10.1.10.59. It's hard to see when I highlight it. And the destination is 10.1.10.56. I can even associate names with this so I can track them a little better, which is why you see this written twice. One would be the actual name, would be the laptop talking to my streaming device, and the IP addresses associated with those. The header length, differentiated services. If you're doing diff serve for QoS, you see the bits that are being used. If somebody says our QoS isn't working right, let's see if we're even sending the right information in here. I'm going to scroll down a little bit more because the next section is TCP. And TCP uses port numbers like 49193 on the source is talking to port 7272, which, by the way, already has a standard name associated with it that Wireshark has already associated with it called WatchMe. Now, I don't know if we're using the actual WatchMe protocol to communicate, but it's interesting that this is a streaming technology that I'm doing a file or a desktop sharing, and it's using port 7272. But notice how we're stepping through the OSI model. If you're struggling to figure out layer 2, layer 3, layer 4, we just did that. MAC address at layer 2, IP address at layer 3, TCP at layer 4. We're stepping through this in Wireshark, and if we scroll all the way to the bottom, if there is any data that that Wireshark recognizes as part of the application, it puts it into this mix as well. I'm going to scroll down in this view. I think I might have seen a packet come through that might have had some application in there, just so you can see the layer 5, layer 6, and layer 7 communication as it comes through. It was this HTTP packet. So here's a similar view of this. We've got a frame that came through. Here's your MAC addresses talking to these. This was using IPv6, so we see IPv6 addresses. Aha! So if you were ever trying to figure out how am I ever going to learn IPv6? There they are, the source and destination. This happens to be, I think, a local communication. The UDP is being used here. And within the UDP, interestingly enough, even though it's UDP running SSDP, it's using underneath that the HTTP protocol. And Wireshark's smart enough to figure that out. It's not running on TCP port 80. It's using something else, but underneath the app uses this, and it's Microsoft's Windows Peer Name Resolution Protocol. And it already broke it out for us, showed this piece, and there it is. You can see the actual information. That's a lot of data. That's a lot of stuff to pour through. Just in a couple of minutes, I've taken you probably deeper than you really wanted to go, the person who asked this question. But when you start working with Wireshark a lot and you become familiar just with the mechanics, I'm capturing, I'm displaying, I'm filtering. If you can capture data and you can display data and you can filter data, everything else at that point is you trying to understand the communication process. And that's the really valuable part. It's anybody can capture data. Anybody can display the data. It's reading it. I was fortunate enough to marry someone who was not in technology. So she knows everything there is to know about the heart, the human heart. And there are these big 12-lead machines that people will put on your chest, and they'll measure just these 12 different areas of the signals coming off of your heart. And she's pulled up these sheets showing this that to me look like nonsense. And she looks and goes, hey, this guy's got a bad aorta right there. You can see it. It's right there. See? Right here. It's right here. I'm looking at it. I don't know what you're talking about. Was there an earthquake? What happened there? I don't understand what any of these things are. But she can look at that and immediately know. You need to be the same way with Wireshark or with a protocol analysis tool that you use so that you can look at this and go, oh, I know exactly what's going on there. I can filter this out and look at communication. I know if the slowdown happens to be related to the network or related to the server. I can see if there's traffic coming in from asymmetric routes. I can understand if I send a request out and I don't get a request back and understand what the trace is telling you. So that's an important part of this, is to be able to not just understand what I need to know for the certification, but also go through the process of understanding what you need to know for the rest of your career. If you can understand this, no matter where you go in IT, you'll be able to do anything. If you're a programmer, you'll be able to program better. If you're in database management, you'll be able to do databases much better because you'll know exactly the way the databases are talking to each other. If you're somebody who works a lot with server management and you're having server management problems, people sending information back and forth, from those servers, you'll be able to troubleshoot it and be able to say immediately, it's not my servers, it's getting as far as the router, and then it doesn't go any further. Or we're sending it out one direction, it's coming back in another direction. I know this because I'm looking at the MAC addresses. That's pretty good stuff. If you want to know more about Wireshark, we'll have a link later on where we will talk about that. But don't miss that opportunity to use Wireshark to be the thing that helps you through understanding the OSI models from the layer 2, the layer 3, the layer 4, and the layers 5, 6, and 7 we tend to cram usually into apps. There is a little bit of delineation in there, but when you're looking in from a protocol decode perspective, sometimes there's a layer 5, certainly layer 6 and 7 we squish together. Time for you to answer a question for me. Which of these networking devices makes a forwarding decision based on MAC address? If you go to vot.rs, you can answer this. The answer you'll find under number 827898. Which one of these, don't answer in the chat room, which one of these networking devices makes a forwarding decision based on the MAC address? vot.rs 827898. Let's pop that up on my screen so we can see a little bit of that. I will find it here. Got a big list. Microphone is in the way. Find that piece. Let me hide it so it's a secret, so nobody knows the answer. You need to go to vot.rs, the number 827898, and the answers, or the ones that I have as options for you. Which one of these networking devices makes a forwarding decision based on MAC address? A router, a gateway, a switch, or a repeater? So there's 3 networking devices. They all work very differently for determining where traffic goes. They pull traffic in. They make a determination on where that traffic goes based on something. One of these makes that decision based on a MAC address. Is it a router, a gateway, a switch, or a repeater? Let's see. We've got 29 respondents, so let's reveal the answers, or at least what you have chosen in your answers. And we have 10 people have said router. 1 person has said gateway. 21 people have said switch. Nobody has said repeater. So those of you that are familiar with repeaters and how they work, you know it's a pretty dumb thing that just takes data in, shoves it out the other port. So it didn't fool you there. But there, we've got a sort of a divide here. We've got a 2-to-1 here on the switch to router. 22 people have said switch, 10 people have said router. And as you can imagine, the 22 people, they're the ones that in this case are absolutely correct. A switch determines where traffic goes based on a MAC address. A router really doesn't care about MAC addresses, does not look at those at all. It looks at the layer 3 IP address to be able to do that. So what is that about then? Let's take a step back then and look at those pieces and try to get an understanding of the differences between all of these. And this question comes to us, compliments of RR. I think this one came off Facebook, which is, what is the difference between a hub, a switch, and a router? These are all doing very different things associated with it. Hubs you just don't see anymore. Hubs aren't available out there anymore. You can't find them. We commonly call those multi-port repeaters because the way a hub works is traffic comes into one port on the hub and it just automatically sends all that traffic out the other ports. There's no thought process whatsoever. There's no intelligence to the device at all. It takes it in one port, shoves it out all the others. Already you can think that's not very efficient. That's absolutely right. It's not very efficient. But this is one where this was all we had in the beginning. There wasn't a lot of intelligence in our networking devices. You have data go into one port, just shove it out all the other ports so everybody can see it. That's the only thing we had an option. And if you had the network that got very, very busy, it got very inefficient. It was harder and harder to send traffic as the network got busy. It almost an exponential curve there as things got very, very busy. You commonly only see hubs at 10 and 100 megabit. You can't go into any store and buy one. Nobody makes them anymore. You can't find them. If you're doing network analysis at 100 megabit, they're very, very useful because you can plug in and sort of tap the connection right in the middle. Now these days, if you want to tap connections and you don't have a hub, you have to buy a specialized tap. And if you get into gigabit speeds, you're going to have a specialized tap anyway. There's just no hub that you're going to find anywhere. But if you're on eBay, you're buying one used, you see one at a thrift store, and you want to be able to tap into a 100 meg or 10 meg connection and do network analysis with your Wireshark, that's something that you can use. I used to carry one around with me all the time. That's the one I used to carry around with me all the time because I never knew when I would have to break a connection, get into the middle, and start grabbing packets and understand exactly what's going on with those. Let's look at switches. A switch works a little bit differently. Normally, when we were using these hubs, we realized this wasn't going to be very efficient for us. The upgrade to hubs, we put in switches. That's because these switches are effectively multi-port bridges. They determine where traffic is going, and they send it there very, very quickly. They do it very, very quickly because most often they're using specially made chips called application-specific integrated circuits, or ASICs. When you look at switch manufacturers, they'll tell you, oh, well, we have a fantastic ASIC. It's very fast. And that's what they mean, is that the chips, the hardware inside of them, is built to switch. That's what they do. This makes the determination of where traffic goes based on MAC address. So traffic goes into the switch. It just doesn't broadcast it to everybody by default. It has a big table in the switch that it's built over time by watching all of the traffic. It says, oh, you're going to a very specific MAC address. Wait, I know where that MAC address is. I've already seen that MAC address communicate to me on this port over here. I'm just going to send your traffic out that single port. There's no reason to send it out anybody else on the switch. That's pretty efficient. You can have two people talking to each other on one part of the switch, another two people talking to each other on another part of the switch. They never know each one is talking to each other, completely separated. And so I can get very high speeds and very efficient network communication that way by having the switch be very intelligent about the way it works. These usually in an enterprise network in the core just have tons of ports on them, hundreds of ports that you can switch between. There's fiber, there's copper, there's different speeds. These switches are very, very intelligent, and they're usually designed to be very high bandwidth with tons of traffic going through them. There are, of course, smaller size switches that might go in a closet. I have a 24-port switch that I use here in my studio. It is perfect for plugging everything into, carving out different VLANs if I wanted to, and they can all communicate to each other at direct speeds, which is great when I'm storing stuff off to a storage area network device. I can just dump everything onto the NAS that I have and work that way with those pieces. This is a layer 2 device, as I say. So this question always comes up in the chat room. It always comes up during the month. I get questions about this. But wait, a layer 3 switch, that's layer 3. I've got in my documentation, it's a layer 3 switch. There's no such thing as a layer 3 switch. There's not. A switch is a layer 2 device. But what some manufacturers will do is add additional software to the switch that allows you to route between different ports. You effectively can turn part of the switch into a router. That's not a layer 3 switch, that's a router. So when they say this is a layer 3 switch, you can cross over through the words layer 3 switch and write right next to it router, because that's what it is. A switch is layer 2, a router is layer 3, and ne'er the twain shall meet. These work at completely different levels. So don't be confused by that. Well, we are all confused by that. I say don't be confused. It's confusing because they're telling you it's a layer 3 switch. What they're trying to tell you is you don't have to buy a router. I can simply route inside of this device. There's value there. But the way that the industry has now positioned it to us, especially for people that are trying to understand this technology, that's really confusing. So in your mind, every time you see the words layer 3 switch, cross it out and write the word router in your head. And that will help you very, very, very much, because a router works completely differently than a switch. Our question I just asked you earlier was, what device uses MAC addresses to determine where traffic should be forwarded? That's a switch. A router could effectively care less about MAC addresses. It's not using those to determine where traffic is going. A router determines where traffic is going based on the IP addresses, the layer 3 address of the traffic that's coming in. And that's why you'll hear that term layer 3 switches. It's a router is what it is. Just keep in mind, layer 2 switch, layer 3 router, and you're going to be just fine on your Network Plus exam. This is usually also connecting different types of media. A router might connect all Ethernet together, or it might be connecting Ethernet to a serial port on a WAN. There might be fiber ports on that router, all between different subnets. So when you look at the back of a router, it will have a different set of characteristics associated with it. Also, routers don't have hundreds of ports on them generally. They generally have a set of ports. Maybe the highest you might see, 24, maybe a little bit over that, but not much more. Certainly, you can have very, very advanced routers out there, but generally routers are connecting just a handful of subnets to each other. You don't need a lot of interfaces for something like that. That makes it very, very easy. And that's why when we looked at our breakdown of the protocols, we saw MAC addresses at layer 2. If I use the right mouse here, we can actually see MAC addresses at layer 2 So the MAC addresses, we can send information back and forth on a switch. IP addresses, that's exactly where a router would come into play. And if you even go above that, things like firewalls might also look at port numbers, for instance, to be able to send those. So if we're trying to determine how traffic gets from place to place, that's a great place to start. Understanding the difference between repeaters, hubs, routers, switches, that really helps, especially from those scenarios. Let's also now take a moment to thank the sponsors of this month's study group. This is the folks at GTS Learning that have come up with some interesting things. I talk about their freestyle all the time. They have online all of their books. They have tests available. You can go through sample tests. That's a big question I get all the time, is where can I find some really good sample exams? They have them. They've taken my videos and integrated them online into all of their materials. So as you're reading about routers in their book and you see that there's a test about routers, right next to that's my video about routers. You don't even have to hunt around for pieces like that. But they've added a new piece to this, which is online labs. If you've ever wanted to do your own packet traces, you've wanted to set up an Active Directory server, you wanted to start doing telnet between those, you want to do some encrypted communication, you want to capture the data, you don't have a lot of machines in your lab, that becomes an issue. You have a laptop, and that laptop may not even have the resources necessary to run multiple virtual machines on it. And even then, you'll have to have all the operating systems. You have to install them yourself. You have to put the software on. You have to make sure it talks to each other properly. And that can be a lot of work. But they've already done this in their labs. If you go out to professormesser.com/netlabs, and you'll see exactly what I'm talking about, and you can see some samples that are out there and some videos that are there. One of the things that I find nice about the labs is I can go on and use them as if they're a machine that's sitting in front of me. It's a remote desktop type connection to tons of different machines, and they've already set up these step-by-step labs that interactively take you through step by step by step of exactly how to perform the packet capture, how to analyze the ARPs, how to see these protocols. So you're not going to change anything on your PC. In fact, you could go in and change parts of these virtual machines, and if you mess it all up, that's okay. You just restart it, and it starts fresh again. You can't really break anything associated with those. They also will normally offer these labs alone for $159, but I had them come down and give us a break. I said, you're a sponsor. Let's really offer something people can use. So they have a special $99 for just the labs if you use the coupon code NETLABS. And you can get that for $99. If you'd like the idea also of their big freestyle, where you can have the book, you can have the videos, you can have the tests online and the labs, they bundle all of this together for $149 by using that same coupon code of NETLABS. Something that I think when people are trying to get into doing a lot of these things, I have a big lab now, but I didn't used to have a big lab. It didn't used to work that way for me. It was one where I had to build this up on my own. It would have been nice to have something like this that I could simply go to a website. I could go to the courses and go to a Network Plus configuration and start running the labs that are here. This is the actual freestyle labs I've logged into. I've connected to the labs. And here's the modules: configuring a network adapter, ARP and packet analysis, using Wireshark to capture packets. That would be interesting to run. It's not even on my machine. It's in a lab somewhere. It's going through all the practice lab information that's there. Let's go through now, and it even gives you some prompts here. And on this lab, there are 5 different virtual machines I could choose from. Let me move my big head out of this so you can see it. So if you wanted to start up a machine and use it, you just click on that machine, it turns on. You want to start up an Active Directory server? Let's do that one too. We'll click on that, it turns on, and you can see it starts, the little icon at the top tells you it's doing some work. So that's the way that they've already set up all these machines for you. They've already got everything running in their environment. And then let's look at these exercises, like using Wireshark to capture packets. They break out for you the exact process of doing this. Here is the step-by-step. Here's investigating the ARP cache table. Here is exercise 2 with using Wireshark to capture the packets. Here's the step-by-steps. And it even shows you, here's what you should see on the screen when you're using the lab. I love this idea of being able to do that step by step by step. You can't mess up. You can kind of do it yourself, and you can kind of see what's going on there. And at the end of the lab, there's more information that tells you exactly what's going on as you step through it. Scroll through this piece, click on that button. You'll be able to work with those as you go through and start using the lab. I worked with not just the Network Plus labs they have labs for Security Plus, they have them for A+. Started playing around with one machine last night just to see what I could do on it. It's a full Windows operating system. So I can go into the Active Directory server. I can add and remove services. I can change it however I'd like. What a great way to start working with these and get a feel for how to get these things running, but not change anything on my computer. So you may want to start looking at what they have available for working with those labs and making them, and maybe that's something that works for you. That way you can go through your entire Network Plus certification, do all of the labs, be online, be anywhere, because you're using a remote desktop. It doesn't require a lot of bandwidth. You can do this almost anybody's network connection. Makes it very, very efficient, and then I don't have to change anything on my machine. I don't have to have a virtual machine running. I don't have to dual boot. I don't have to do any of those things. It makes it extremely easy. And when these machines get started like this one has, and I connect to it, now it's like I'm sitting in front of that device. It's like it's running on my machine. We'll start up the Java piece here that does the remote desktop, and now I'm able to access this operating system and use all those pieces. Very, very, very nice to have. I was very impressed. As I started going through, I started looking at okay, here's a lab that does this. Wait, there's another one for another chapter. And there's a third, there's a fourth, there's a fifth. There's all of these different labs that you can use. I was quite impressed at the number and the diversity of the different options I had available to me. And then I started using it and thought, well, gosh, I've got a whole Windows machine that's now available to me. It's got applications that are already loaded on it. I could run, you can't see it on your screen, but I've got little icons at the bottom. This is an Active Directory server that's already set up on a domain, and I can start messing around and playing with the Active Directory pieces. What a fantastic way to go about using some of these. And it's all in a browser. And once you're done with this, you can go back to another page in the browser and do something else. No, I want to go back to that server and see what's going on. I want to use Wireshark. It's loading up Wireshark right now. And it's all in that self-contained network. So you really can't go wrong. Something to think about. I'll give you that screen again that shows you NetLabs is the coupon code. And we thank GTS Learning for being sponsors yet again of our study group. I have questions that came in from you about the Network Plus certification. And I think when you're ready to take an exam, there's a lot of questions on the material on the exam, but then there's questions about the exam itself. One of the questions we got was, do you need a lot of experience to pass the exam? Well, why I asked this one? And the answer is that it depends. The exam itself is one, if you've ever gone through the exam requirements, there's a lot of technical details in there. A lot of things you need to know about, not just of networking, but of security. There's a lot of things you need to understand about how communications on the network, on the protocols communicate to each other. Routing tables, you have to understand the routing process. A lot of those pieces can be a bit of a challenge. If you have experience in networking, then you understand it a little bit better. If you already know how to do things with working through all of the pieces of how to do a packet capture, and you've done packet captures before, and you've worked through the process of trying to understand, what do I need to do to get that packet capture running, and how do I understand what's in the packet capture? A lot of the things on the Network Plus exam are going to be a lot easier for you. And you'll find as you're stepping through the pieces that you don't have to worry so much about the details. You just need to know what the exam gives you. Now, I did my Security Plus exam first, then I did my Network Plus, then I did my A Plus. But I already had a lot of experience in the industry. Generally, CompTIA recommends you get A Plus and then go to Network Plus. I would say that might help, but those two exams are so different. You could start with the Network Plus exam as your initial exam if that's what you were trying to do, and you'd be fine. So I also would not say that you need a lot of experience. You don't need any experience, but it's going to take a little bit longer to go through the details because Network Plus will start you at the beginning. They'll start you at the very beginning of what you need to know. You're not thrown into networking. So even if you have only a little bit of knowledge of IT, you'll be able to jump into the Network Plus topics. You'll probably need to study a little bit more than someone who's been doing this for a while, but I think it's still a very, very good entry-level exam for understanding those networking pieces. Another question that came in, this comes in a lot, is we get a lot of port numbers, and this is very common question to get, not just on this exam, but on other exams people ask me about, but the topic is just different. But it's the same question. And the question is, I'm going to read this question, then I'm going to decipher it for you. How important is it to memorize port numbers for the N10005 Network Plus exam? BC asks. The question really is, there's a lot of memorization here. Do I really have to do that? So it's sort of a catch-22, isn't it? Well, there's in this rote memorization. HTTP is port 80. HTTPS is port 443. NTP is TCP port 123. There's a lot of memorization on all of these exams. And a lot of people will say, well, I'll just use Google. Why do I have to memorize? If somebody wants to know the port number for NTP, I'll just Google it. But my response is, you can't do that for everything. You can't hop in your car ready to go to work and think, I have no idea how to drive this. Let's Google it. I have no idea how to use this key. Now what do I do? Well, let me Google how to. You have to memorize something. And I understand this is different, and it's a different kind of technology. It's port numbers, but these numbers that you're being asked about are important, and you'll be using them throughout your career. You'll be using them to configure firewalls on a local machine. You'll be using them to understand your protocol decodes as they're going through the network. After a while, they even become second nature. You don't even think of them anymore as something you need to memorize because you're doing it all the time. Sort of like singing a song over and over. You get to a while, you're just saying the lyrics. You don't even think about the lyrics anymore. It becomes the same way with these port numbers. I recognize that it is difficult to do rote memorization. You're using flashcards. You're trying to memorize all of them. It's a challenge. But you will be asked these things on the exam. Now, I will tell you, the section for understanding port numbers is such a tiny little section of the Network Plus exam. And I'm going to give you that thing that I say every month about every exam, and you're sick of me telling all of you this, but it's absolutely true. Go out, get the requirements from the CompTIA website and read them. They will tell you how much port numbers you would ever need to know. They tell you exactly what port numbers you need to know, but you'll notice the port number section is a really tiny section that's in a smaller section. There's a little bit of a number of domains, a number of sections under a single domain, and there's a number of domains. So you might get one port number question. You might get two port number questions. Probably not going to get much more than that on your Network Plus exam because it's such a small amount. But the only way you would know that is if you went out and downloaded those exam requirements. CompTIA gives you everything in the exam requirements. They are very different than other companies this way. Microsoft doesn't even come close to giving you this level of detail. Cisco doesn't even come close to giving you this level of detail in what you need to know. This is a checklist you can go right down and use before you walk in the door of your exam. Make sure you take advantage of that. So if you're trying to figure out, should I be spending 12 hours memorizing port numbers? If you look at this objective list, you realize you should absolutely not be spending 12 hours. You should be spending 1 hour and then trying to learn the other things on the exam. If you can answer 6 questions correctly and miss the port numbers, which might be one question, you're much better off spending your time studying those other 6 questions. And another question I got was, does A+ and Network Plus count towards any other cert? William asked this one. And there are some certifications that used to use the A+ and the Network Plus and the Security Plus exams towards what they do. And some of those may still exist, but you'll want to talk to, you're going to take a Microsoft exam, a Cisco exam, a VMware exam, an exam from another company that may not be so well known. They might use one of these other types of exams to count towards what they're doing. So make sure you go out to those manufacturers and look through their lists of things. I'm noticing fewer manufacturers do this these days, primarily because people like Microsoft have effectively created their own entry-level exam. Cisco has effectively created their own entry-level exam, and they want you to take theirs to be able to do that. So we're seeing fewer numbers of manufacturers accepting the A+ and Network Plus towards credit for their certifications. There's still a few out there, but it's not quite what it used to be in the past because of those types of changes. I mentioned to you that there was a link of the moment to look about and things that you would want to see. And the one that we have looked at this week, and I think it's important that you go there, is Wireshark.org. Download Wireshark. It runs in Windows. It runs in Linux. It runs in Mac OS X. It runs in anything. So load it on your machine and get comfortable with it. There's also on the Wireshark wiki are trace files that people have already captured on many different topics. Somebody downloading something from a web server, somebody going out to an NTP server, somebody doing SQL communication. So you might not have a SQL server at your house, but you can load up a trace file that somebody else has already created that shows SQL server communication. And that can be really useful for understanding how that communication takes place. And very nice resources there in forums. There are some great Q&A and tutorials that are out on the Wireshark website. You can find all of that on Wireshark.org. This month, like every month, there are things that you can do to really help what we're doing here at Professor Messer. If you go out to our YouTube channel and subscribe, that is enormous help to us. You will also, of course, have the option to receive updates every time I put a video there, but you can also turn that off. Having a large number of subscribers actually helps us quite a bit with the folks at Google and YouTube, and it helps me provide more resources to you. I highly recommend and hope that you will go out there and do that. If you'd like to follow what we do on a daily basis, and I'm starting to use Twitter a lot more just for things that are going on around the studio, and when I put new videos out, you'll find that at professormesser.com/Twitter. You can always follow us there. I also have a Google Plus that I put everything on, try to duplicate no matter what you like to use. If you're not a Facebook person, not a Twitter person, but you're Google Plus, that's okay. I got you covered. Go out to professormesser.com/Google Plus, and Facebook, of course, is professormesser.com/Facebook. I have also want to thank my sponsors again this month, doing a great job of not only sponsoring what we do here, but providing resources to you. That's the folks at GTS Learning. You can go to professormesser.com/netlabs, use the coupon code NETLABS to get those discounts that they've offered just for you guys. And again, I thank all of you. Thanks for attending live and participating in our Q&A. Thanks for sending me the questions throughout the month. And thanks, of course, for always providing that feedback of the things that we're doing. We're going to keep making these videos just as long as you keep watching them. Thanks again for also joining us on this month's Network Plus study group, and we'll see you next time. Thanks, everyone.